Good morning to everyone. Good morning to everyone, all the students in the class. This is specifically for the cohort of my class. I want to issue a statement. I've gone through the syllabus of, there's some structural changes in the curriculum for BTEC Physics and Chemistry. What I want you to do is to use these words more and more in your coursework reports. So I'll be looking for these words. I've got a list here, and I want you to use these words. Take a screenshot now and use these words in your report as much as possible. It will increase the quality of written communication, quality of documentation for your report writing. So I want you to actually, so I'm going to read them out now. This is misclassification, taxonomic error, prior distribution, corresponding to the model parameters, frequency. Instead of saying quite a lot, large number, you say frequent or frequency. Corresponding to the model parameters, does it does it comply with the hypothesis, or does it comply with the null hypothesis? So if it complies with the null hypothesis, you say corresponding to the model parameters of the null hypothesis or hypothesis. All right. Prior distribution prior the commencement of the investigation. Taxonomic error, which is classification error, classification in terms of whether let's say materials, right? What kind of material it is? Is it a single layer, single atom material? Is it a multi-atom, multi-layered, multi-atomic material? Is it polyatomic, diatomic, this and that? So this is what you have to clarify, what material you're discussing and the investigation material, all right? Then you go to asymptotically inconsistent, which means it's very, very inconsistent asymptotically, and as a function of time, the inconsistency increases and it moves further and further away from the norm, from the true value, not the norm, not the precise value, but the true value, the accurate. So it's asymptotically inconsistent, which means it's increasingly incorrect, inaccurate. We're moving away from the concept of accuracy. So if you have a true value would be, so it's moving away further and further and further from the true value. Then we have elemental resolution decomposition, is when you decompose a vector into its dimensional analysis. Micromechanics means how you resolve a vector, how you carry out the calculational analysis. Heteroscedastic means it's all over the place, it's away from skewing, it does not comply with the skew policy, it's away from, it's quite scattered, it's almost stochastic, non-linear and unorganized. Elemental resolution decomposition. Then you have parsimonious, tight-fisted, which means like the result was quite parsimonious. It was very, it was quite accurate. It was precisely, precisely tight-fitted. Like it was precise, but it was not accurate. Framework, discrepancy, log posterior probability, precision proportionation, proportionation, tertiary, quaternary. You have to use, so there's primary, secondary, quaternary, and tertiary. So if you're doing, if you are reviewing an investigative, if you're reviewing a review, then your analysis becomes tertiary. Someone who reviews, so a primary publication is an investigative analysis. A secondary investigation is a review of the investigative analysis. A tertiary, document is a summative review of the review, and a quaternary is a review of the reviews of the review of the investigation. Structural risk minimization, protocol optimization, crude upper bound, crude lower bound, fractional error, systematic error, human reaction error, dense, densitometric, density, dilute, dilution, solubilization, solubility, predictive analysis, predictive validation, like the prediction validates the model parameters, commutative compartmentalization, commutative summation, commutative dissociation, commutative compartmentalization, commutative summation, estimation schematic, drawbacks, advantages, disadvantages, drawbacks, cross-validation, convenience, inconvenience, convolution and cross-party communication, supervised predictor, correlation indicator, screening schematic errors. Now, taxonomic, human reaction error, cross-institutional lag, interdepartmental dissociative delay, impractical hearing, dichotomy, conditional outcome, skew, left to the right, negative, positive, penalization, discriminant analysis, which means how good are your results in view of the original investigative analysis carried out on the same material. So let's just say, so discriminant analysis means, let's just say, this is the original result, the original investigation, photon energy, and this is the original photoelectron energy map, right? What were your results, and where were the deviations, and why did the deviations take place? Was it because of human error, systematic error, machine errors? Was it because you didn't use the same material consistency? Was it was it a single layer? Was it a single layer material? Was it a adsorbate? Was it adjuvant? Was it a catalyst? Did you use any catalysts? Did you use a single atomic layer of a catalyst, or do you use a lump of a catalyst? And then you can also look at yeah, so let's just say that was the investigative analysis results from the original investigation that you're reviewing. And then you find another paper which has, a deviation, right? This one. So that intensity does not match that much, right? Where are the differences? Why is there a lot of noise? How do you denoise it? Why didn't they denoise it? Where are the denoising mechanisms, right? Then you come over to multi-resolution analysis, where you analyze the results through a higher resolution analysis algorithm. Okay, so you plot the results in the software and you denoise it. You click on denoise, and localized likelihood, model collimation. Collimation means to channel everything. Combination collimation. Collimation means to channel. Model combination. Model combinatorics. Multi-resolution analysis, false discovery rate, which means false positive, false negative, true positive, true negative, sensitivity and responsivity, poor remedial combat tactics, and then factual deduction, inference and deduction, entropic error maximization, stochastic stochases, which is very close to randomized radiative emission, and then adaptive modulatory filtering. So these are some of the words I want you to use. I'm going to print them out and distribute a list. I want you to fit them in your report writing to increase the quality of communication. Now, what your aim is as a science BTEC physics, you're getting trained for a physics degree. What you need to do is to learn to write like these people, how they write. In this chapter, synchrotron radiation has been applied to the study of silicon-germanium interfaces in order to probe the electronic geometric structures configuration. The methods and results which will be discussed are categorized into photoelectron spectroscopy, X-ray absorption fine structure spectroscopy. Right? The technological importance of the semiconductor interfaces has grown extensively over the last few years, primarily because of the recent success of the advanced growth techniques such as molecular beam epitaxy. If you don't understand this, you need to Google it, you need to type it in and understand what MBE is. And you don't have to use the full name every single time. You can write in the beginning of the report. You need to list all of the abbreviations, and then I'll go back and forth and ask and see what MBE is and XAFS is, right? And then metallo-organic chemical vapor deposition. So there are a lot of catalysts that act by getting deposited as a single atom metallo-organic chemical vapor deposited layer, and then they end up providing catalysis for the reaction. kinetics, high quality semiconductor heterojunctions, homojunctions, superlattices, molecular lattice, atomic lattice, metallic lattice. Amongst the most widely studied semiconductor heterojunctions are those involving 3 to 5 combinations such as gallium arsenic, gallium astatine, aluminium gallium astatine. And then you have silicon and germanium are the primary components. So then we move on here, and when we look at the formulaic derivation, these are statistical formulae. They're not exactly, they're very high approximations. So they're not. What it really means is, it's actually this actually means this one. I'm going to just simplify this one for you. What this really means is, okay, so this is an exponent of the exponent. This is what you need to realize. It's an exponent of the exponent. This is one expression. This is one little expression. Then you have a partition coefficient here. Descriptant. That's a descriptor. Then you have an operator. This is the operator. This is the anatomy of the equation. You have the equipotential. You have the factorial magnitude equalizer. Then you have the sigma, the summative motor. Then you have the actual real operator motor. Then you have this part, and this one is where you do the this is the part which propagates the equation, and then you have these partition coefficients. And then you have the first expression, second expression. So all of the calculation will now sort of be generated through the sine into 2kr of the j plus 2 sigma, and then k plus the k would be constant, sigma, this phi would be constant. So you only have to just like radius. You have to focus on the radius. That's it. So this is how the equation is born. And then what most people don't realize that this is an exponent of the exponent. This is what it is. It's up, 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 right? That's how it is. So if you wrote it, it would be e x to the e x to the y. That's what it is. That's what it really is. It's going this way. It's, and so this is what it is. X-ray absorption fine structure studies of silicon germanium, silicon germanium, silicon germanium. You'll be coming across silicon germanium. They're the driving force behind semiconductor, superconductors, all of the type 1, type 2 superconductors. So they're the driving force in material science. So this is what you need to realize. This part of Unit 18 and all the parts of units of physics, they are filled with transition metal chemistry. Transition metal chemistry is the basis. This is why I always urge all of my students to take special interest in transition metal chemistry. You have to take an immense interest in transition metals. So in order for you to survive at graduate level. Again, this is the equation. Don't get intimidated. This is how it starts, right? And then for density squared, sine angle minus density whole squared, you resolve this first, and then gamma is a factor, you square it, and then that's how you do it. And it's a bit like Compton scattering as well. So Compton scattering, look at this. Compton scattering, it's a bit like that. It's diffraction, scattering, diffraction taking place at the same time. A lot of systems are intermingled, interoperative, and they are, contemporaneous. So there's diffraction taking place, angular scattering taking place, quite a lot of phenomena at work. So, angular refraction, total internal refraction. There is, interlattice reverberation, adsorption, substrate modification taking place. So quite a lot of phenomena taking place together. Monochromators, dichromators, polychromators. So yeah. I want you to understand a lot of phenomena take place together. And so you can see here there's refraction, reflection, scattering, diffraction, all of them taking place at the same time. And, and we all understand n lambda, we all remember n lambda d sine theta, right? So we all remember that, right? So this is the expansive modification, modernization, and complex, upgrade of that formula, n lambda equals d sine theta. That's pretty much it. So then I'll talk about it in the class. Yeah. So there it is. That's it. So this book, I'll be bringing over this book. This is excellent, and I've used it for many years now. Synchrotron radiation research advances its interface, surface interface science. Okay, so I'll bring it over, and I'll do a few photocopies out of this book as well. Thank you very much. Cheers.